In this demo, the main objective is to present the first building blocks of the bIoTope ecosystem, keeping a special focus on how developers can benefit from it. This demo is primarily about Work Package 3, where Work Package 4 and 5 will now start developing more agnostic and intelligent services on top of it. Here a short summary of what I'm going to present now. As a starting point, let us first discuss what today's IoT looks like and what are the main challenges from a developer perspective. Here I try to provide a simple overview by essentially focusing on technologies that will be used in the demo. The main message that I want to stress here is the fact that product vendors usually define very specific APIs to access product-related data and services, which inevitably results in siloed apps where interoperability is difficult to achieve across platforms. The major challenge today for developers and businesses is to find a way to discover and access domain and vendor-specific services in a standardized way. In this respect, let Jeremy be our developer in this demo who is facing this problem and looking for potential solutions. Recently, Jeremy heard about an IoT ecosystem developed in the framework of the bIoTope Horizon 2020 project. This ecosystem offers a service marketplace that standardizes a way to access services. To be more precise, this is made possible using the OMI standard, standing for Open Messaging Interface, which provides generic read, write, and subscription mechanism for peer-to-peer data exchange. The bIoTope Service Marketplace also provides a basic and generic way to describe services thanks to the ODF standard, standing for Open Data Format. This standard can be combined with more elaborated vocabularies, either domain independent, such as schema.org and SSN, or with domain-dependent vocabularies such as Daytech2 or MobiVoc, which focus on smart mobility applications. Jeremy, after having had a look at the bIoTope Service Marketplace, that I will show later on in this video, has a great idea for developing a new app. This app consists in notifying the end user, when needed, about the most appropriate bike parking spot, taking into account the bike availability in the surrounding area, as well as the weather preferences. Let us have a look at the final app first, and then I will explain how Jeremy can develop this app thanks to the bIoTope ecosystem. So the end user has to activate his app to specify his home address. Let's say he's living 47 Rue Saint-Jean in Brussels. Okay. He has to specify the maximum distance he's willing to walk during bad weather to reach the parking spot. Let's say around 200 meters and up to 500 during good weather. Then he can specify when he wants to be notified about the available parking spot and the number of available bikes, so 9 a.m. And then the end user can choose a smart bulb technology, a Philips Hue light in this demo, to receive a visual signal about the availability rate of the bikes in the requested area. But this will be exemplified in this video in a few moments. So I apply. Okay, I can see here that the weather is bad today and that there are 4 parking spots that meet my requirements in terms of distance. And I can see in real time the number of available bikes, so 3 for example on parking spot 46. So today the weather is good, so I have more options in terms of parking spots. And here I can see, for example, that the parking spot 35 doesn't have any bike left, so I should not choose that one. We are now 10 minutes before the departure time, and as we can see, the bike availability rate is low on the different parking spots. For the demo purpose, we consider that if there are less than 3 bikes available on each parking spot, the light in the house should be set up with a red color so that the end user knows about the critical situation, that he has to hurry up and carefully check the app results before leaving. For example, here, half of the parking spots have less than 3 bikes available. As a consequence, the light is set up with an orange color to notify the end user about the fact that the situation might become critical in the coming few minutes. To develop this app, Jeremy has to access the real-time data from the Brussels city. Again, without caring about what infrastructure or platforms are generating those data. To this end, Jeremy needs to access the set of OMI nodes in Brussels that publish bike parking spot related data and services, including among other things the number of available bikes per parking spot. How Jeremy can discover these nodes, this will be discussed and shown later on in my video. Jeremy, in addition of integrating the end user's information and preferences, also needs to access a weather station close by the end user's house in order to get the most accurate weather condition. In this demo, the NetAtmo technology has been wrapped using OMI-ODF to expose weather-related data to the bIoTope service marketplace. Nonetheless, from Jeremy's perspective, he doesn't have to care about this, meaning that this job is done by the one who publishes weather-related data and not by the consumer of the service, Jeremy in our case. One may wonder, obviously, whether this wrapping process for the publisher is a complex process or time-consuming. I do not discuss this in this demo to avoid making you confused about the whole video's flow. Because remember, the focus here is on showing how developers like Jeremy can create innovative services across platforms based on the assumption that platform-related data and services have been exposed to the bIoTope service marketplace. Nonetheless, if you would like to better understand how to install and set up your own OMI node, meaning to publish your own services, please refer to the tutorial video available at the following URL. Once Jeremy has discovered and accessed the necessary data streams, he has to develop the intelligence that will fulfill the service that was presented before in our video. It must be noted that the intelligence proposed in our app is simple on purpose, since the main objective is to explain how Jeremy can combine information sources coming from different platforms, and not necessarily to develop complex reasoning and prediction services at this stage. In fact, this is a kind of work that will be carried out in our package 4, which focuses on context-aware services. Now, I will present in more detail the different bIoTope tools that Jeremy is going to use. For example, to find the OMI nodes on the service marketplace that publish relevant IoT data sources needed to develop his app. The bIoTope service marketplace that I am referring to and that benefits Jeremy when looking for specific IoT services, such as weather-related and bike-related data, is referred to as IoT-BNB in bIoTope, which stands for IoT Publication and Bidding. This service marketplace is available at the following URL. In our demo, Jeremy writes Bike Brussels in the search bar. As a result, all information sources currently available on the service marketplace are listed. Each row provides information about the OMI node that is currently publishing the service, a node being linked either to a person or institution entity. Jeremy can also visualize complementary information. Here, for instance, Jeremy can get some information about the number of metadata associated with the service description. We also highlight the format type, XML in that case, but it could be a JSON format since a JSON LD version of the service description will be developed in bIoTope for linked data purposes. We also provide insight into the number of standardized vocabularies used in the service description, which can be of great value for integrators to more easily understand and create cross-platform services. IoT-BNB also provides feedback about whether Jeremy can access the service for free or will be charged for it. It gives insight also into the service reputation, meaning whether people are in general happy of the service they paid for or have had bad experiences with the service owner. For example, due to payment issues or because the service owner is not really reactive when asking questions. Finally, Jeremy can have a summary of what services he's going to use, here corresponding to the bike parking spot related live data. He can also adjust how long he wants to access those services. The prices given here are completely random for the moment, because so far we didn't pay much attention on defining frameworks to help publishers to assess the quality of their services, and accordingly to fix reasonable prices. However, the definition of such frameworks is clearly an objective of the project. Once Jeremy decides to go and pay for it if needed, there will be a need for new micro-billing frameworks to enable microtransactions between smart objects and related owners. Here, we briefly illustrate one potential micro-billing workflow that will be investigated and supported by IoT-BNB. The first thing to be noted is that IoT-BNB doesn't collect any money. It only puts into relation the consumer, Jeremy, and the service publishers, Brussels City and the owner of the selected weather station, so that the money transaction can be realized in a peer-to-peer manner. For example, if the consumer and publishers use a specific cryptocurrency, such as Bitcoin, then IoT-BNB can monitor the digital wallets of all parties, check whether the transactions are successfully achieved, and then provide Jeremy with the necessary access rights. Once all money transactions have been validated, a token or certificate is generated by IoT-BNB and communicated both to Jeremy and to the service publishers, their corresponding OMI nodes to be more precise. Here, red tokens are generated and sent to the Brussels OMI node and blue tokens to the weather station related OMI node. Both nodes will therefore be able to check whether Jeremy is allowed or not to access the service, for how long, what types of operation is allowed to perform, read-only, read-write, and so forth. What's really important to understand here is that once the tokens are generated and communicated to all parties, IoT-BNB somehow disappears from the picture, since data exchanges are carried out in a peer-to-peer manner between Jeremy and the service owners. To put it another way, IoT-BNB is not a cloud-based platform that collects, stores, and analyzes data. It's just an intermediary to find service providers. Then Jeremy can use his favorite integrated development environment, or IDE, to develop his service and associated app. In this demo, we chose Node-RED as favorite tool, which is developed by IBM and enables to wire together APIs and other online services. To this end, the bIoTope consortium has developed an OMI box in Node-RED that I will show in the next slide, but any other visual programming tool could be used instead, a list of existing tools being available at the following URL. So now I'm going to show you quickly how you can benefit from IoT-BNB and Node-RED, for example. So here I'm looking for services in Brussels, for example. I can see that there are different information sources. I can refine my search, for example, location-based, let's say in this area, and then I can see all the available information and services. Here, let's say that I want to access at least the available bikes on the parking spot of ID 59. So I add this service to my cart. Then I can adjust how long I want to access this service, depending on whether it is free or not. I will pay accordingly. So I need to log in. Then there is a billing process that is not achieved in this demo. Now you get the path of the service and the security token. These two information can be used then in your IDE, in our case in Node-RED. So let's move to Node-RED now. So now I'm going to briefly present how you can use an OMI node in Node-RED. So for people who don't know about Node-RED, you have different boxes called nodes that fulfills specific functionalities or services, APIs. Google, for example, provides some nodes in Node-RED. So we developed our OMI node, so you just need to drag and drop this node and fulfill or fill out, to be more exact, the different fields. So a name, for instance, available bikes on parking spots, 59 if I'm not wrong. The path, so the path corresponds to this ID, you just need to copy paste it here. The token for security purposes, so that the remote OMI node will know that it can let you access the service, and then you can choose different operations that you can perform. For example, with OMI, I won't go in detail, but you have a subscription mechanism that you can use, interval or event based, with a specific callback address, for example. But let's use a simple read. Okay, so just in Node-RED, you need to trigger an event to generate the flow, to activate the flow. So we trigger it with a timestamp and we just display the response. We deploy and we send our flow, our event, and we get the response of the remote OMI node. So we can see here that we have a response regarding the parking spot of ID 59, whose value is 6 available bikes at that time. Obviously, this is a very simple flow with one OMI node where I send a request and receive a response. But in the next slide, I will present how we can access different OMI nodes and integrate them to a more complex service, namely the one that Jeremy wants to develop. Here you have an overview of the whole flow that Jeremy developed from the stage of collecting the field data to the development of the app. As highlighted in yellow here and the dashed lines, 2 OMI nodes have been integrated to the flow to respectively access parking spot related data and weather related data. To this end, an interval-based subscription has been defined on both nodes. A third OMI node has been integrated to control the smart bulb. The second part of the flow here represents the logic behind the app. Several processing blocks compose this flow, and as you may have noted, a Google node has been used and integrated into the flow to convert, in our case, the end user's home address into GPS coordinates. The third part of the flow corresponds to the app-related web server. All this clearly shows that Jeremy is able to access a wide range of data sources and service resources using a same OMI box in Node-RED, where only the path and the token differ depending on the service resource, as I explained it before when showing IoT-BNB and Node-RED. Finally, just to show that using the same IDE and the same set of OMI nodes, Jeremy can easily develop other apps targeting other city stakeholders, we adapted the second and third parts of the flow, highlighted in blue here. This new flow and associated app aims to provide the city manager with the possibility to visualize in real time the evolution of the bike availability regarding one or more parking spots, as well as the evolution of the temperature and humidity in Brussels. We can easily imagine how more intelligent flows could be developed on top of this, for example, to learn and extrapolate models of how frequent citizens access the parking spots over the city, and accordingly optimize various logistical activities such as bike maintenance.